All right. We talked about the other day that an inverse trig function has only one solution because of the domain restrictions. Remember, we colored this unit circle, and we talked about if we're looking for an inverse cosine, which is also called arc cosine, that you look in quadrants 1 and 2. But for inverse sine or inverse tangent, you look in quadrants 1 and 4. But if it happens to be in 4, you have to renumber it and name it as a negative. And you can use this colored unit circle on the first quiz we do this on. But if we have to re-quiz on it, which is we did last year, I don't know what will happen this year, but you will not be able to use it, and on the final you will not be able to use the colored unit circle. The same information is provided here underneath your unit circle on your peach sheet. Does everybody remember this? On the peach sheet it tells you your answer has to be between negative pi over 2 and positive pi over 2 if it's a sine or a tangent, and between 0 and pi if it's cosine. Okay, the two tricks, okay? We're remembering to renumber in quadrant 4. And tangent, remember tangent is tricky because it wants to know where is the tangent, square root of 3, and you have to figure that out by looking at the sine and cosine that are on there. All right, we're going to talk today. These are just quick examples. If somebody wants to hit the lights, good. But these are just a couple quick examples. Where is the sine negative 1/2? So using your colored unit circle, do you see where a sine value, which is the y, would be negative 1/2 here? So we have to call it negative pi over 6. That kind of looks like a 5. Okay, one more time. This is a question you might have on your worksheet 20. Yeah. Okay. Where's the sine negative 1/2? Yes, that we're looking in the y value because it's sine, and it's at negative pi over 6 because we can only look in quadrants 1 and 2. All right, the second question is something they ask a lot of on the worksheet, but where's the cosine for? The cosine can only be between negative 1 and 1 if you remember the cosine graph, so therefore this is not possible. All right, another thing we're going to do is composition of these, which is when you put one inside the other. Now, for very specific problems, taking the sine of the arc sine undoes each other, and taking the cosine of the arc cosine undoes each other. Taking the inverse cosine of the cosine undoes each other, okay? But there's times when it doesn't if it's not in the right quadrant. So I always just go through them step by step. Now, what is the step when you have something like this? F of g of x. Do you remember what order we did that in? Yes, this into this, and then that whole answer goes in here, right? Got to go inside out. All right, so you maybe have this on your notes. Is it on 20? Is it on the back of 20 maybe? Okay. It tells you when they undo each other. I don't worry about it. I just go inside out and see if they undo each other. So let's start with 12. 11 is a weird one, so let's go back to it. Number 12 says find the cosine at pi over 2. So again, I'm not doing inverse. So up at pi over 2, the plain old cosine is what? 0. So now it wants where is the cosine 0, because this is giving us the cosine, it wants the angle. So where is the cosine 0 is still blue, so it's here or here, so it's just pi over 2. Everybody okay that those undid each other? No trickiness there? Yes. If it was sine was 0 or?
Yeah, like sine sine pi over 2?
Okay, I think this is your question. Yes? Is that your question? Okay, so the sine at pi over 2 is 1. And where is the sine 1 would be at pi over 2. So yes, the answer would just be pi over 2.
Okay.
Does that help?
Mm-hmm.
They undo each other most of the time, but there are exceptions. Like this, are these going to, on 14, are these going to undo each other? Because they're not the same function. All right, so what is the cosine at pi over 6? I don't know why I picked that one next, but we'll do it. Yeah, right here, cosine at pi over 6 is root 3 over 2. And then it says, where is the sine? Square root of 3 over 2. So now we got to be careful because we're doing sine. So that happens up here at pi over 3. All right, let's try 13. What is the tangent at 3 pi over 2? 3 pi over 2. Now, this is an interesting question. 3 pi over 2 is 270, right? The tangent here, y over x, is undefined. You can't actually do anything with that because where is the tangent undefined? It's undefined at multiple places. So this just does not exist. I would not ask you that on the quiz. All right. Let's talk about 11. Where is the sine? Negative 3/4, and then what is the sine at that spot is what it's asking. So where is the sine negative 3/4? What quadrant would the sine be negative in? Okay. And if I were to draw the sine, this would be opposite over hypotenuse. Everybody okay? Opposite, or y over hypotenuse. Now that's not a 3, 4, 5, by the way, because the 5 would have to be on the hypotenuse. The negative would be here. But all they want to know is what's the sine of that triangle? So what's the sine of that triangle? Look at the triangle I just drew. What's the sine? What's opposite over hypotenuse? Okay. They're just undoing each other. If I have an angle whose sine is negative 3/4, what is the sine of it? Negative 3/4. Okay. Number 15. Okay. Are these going to undo each other? They're not both cosine or sine, right? So I don't think so. We're going to start inside. Where is the sine 1/2? The sine is 1/2 here, right? Be careful, you're looking at sine, not cosine. So we got pi over 6. And then it says, what is the cosine at pi over 6? Square root of 3 over 2? Is that what you meant?
No.
Questions? Doesn't make sense, please ask, because there's not a lot. If you're not following, we just need to go over it again or do another example. All right, let's do 16. Where is the sine negative 1/2? Now be careful. Arc sine negative means we're down here, right? In quadrant 4, renumbered. Negative pi over 6. Then what is the tangent at negative pi over 6? Well, the ordered pair was this over this, right? So tangent would become y over x, negative 1 over square root of 3. That's a comma, sorry. Which becomes negative square root of 3 over 3. That's all number 16. Sorry, I wrote it. Yes.
The last
Yes. Arc sine positive 1/2 had to be in quadrant 1, and then it just wanted what was the cosine there. Any other questions? Did we get 16, or need me to go back over that again? Yes. Where is the sine negative 1/2? Arc sine means find the angle. So on our unit circle, arc sine is red on mine. And I'm looking for the sine, so that's the y value, to be negative 1/2. So I'm right there. And then what it wants is the tangent at that spot. And remember, tangent is y over x. The divisors will always cancel. So I get negative 1 over square root of 3. And then I have to rationalize because somebody said it we did. So we get negative square root of 3 over 3. Better? You get where the rationalized part? Okay. Sorry, I'm going back and forth here too many times. All right, let's try this one. Where is the cosine 2? Yeah, not possible, so then we can't take the cosine of not possible. All right, this is a tricky one. It's not as tricky as we might think because we maybe just talked about it, but where is the tangent negative square root of 3 over 3? This is tricky because you can't see the tangent on the ordered pairs. Okay, negative square root of 3 over 3 used to be what? Well, yeah, we're looking at a 1 over a square root of 3, so the y and the x need to have this. Do you see where that would become 1 over square root of 3, which would become square root of 3 over 3? Okay. Arc tangent, what quadrant am I looking at if it's negative? Fourth quadrant, so the y is negative. And I'd have to have 2's here that went away. So this is the ordered pair that would lead me to have this tangent. And then the question asks, once I get there, what's the cosine? Yeah, the cosine is just square root of 3 over 2. So, well, this part of the question was, what did you tell me, negative pi over 6? Yes? Okay. It really just wanted the cosine at that spot. So the answer is square root of 3 over 2. All right. So what is this asking? Can anybody put it in words? Because you're not going to have me to put it in words for you on the quiz. 19.
Wait a minute.
Okay. What is the cosine at pi over 3? So the cosine at pi over 3 is 1/2. Now it's asking, where is the sine 1/2? One more time. What is the cosine at pi over 3? Everybody's okay with the 1/2 there. And then where is the sine 1/2? And when I do that, it has to be one of these two quadrants, but it's positive, so it's just here. The sine is 1/2 at pi over 6. All right. Do these undo each other? Well, what's the cosine at pi over 3? And can I find the arc cosine at that spot? Is it colored blue or colored for arc cosine at that same spot? Oh, this one says, okay, thanks. Right here it says 5 pi over 3.
Yeah.
Ah, it's tricking you because that's one that doesn't cancel out, I think. What is the cosine at 5 pi over 3? Let me go back here. 5 pi over 3 is over here, right? In your uncolored unit circle. This spot is 5 pi over 3, and the cosine there is what? 1/2. What? It's not an inverse cosine, it's a cosine. Everybody understand why we can be in that quadrant for that question? Because it was a straight up cosine here. Cosine at 5 pi over 3. And we got, what, 1/2? And then it says, where is the cosine 1/2? There we can't answer 5 pi over 3 because the cosine can't be, it has to be between 0 and pi. The arc cosine or inverse cosine. So which quadrant are we actually going to look in if it's positive? Is it quadrant 1? And in quadrant 1, what has a cosine of 1/2 would be pi over 3. All right, these are kind of nasty questions that I don't think I asked on the quiz, but let's do it together for practice. Where is the sign positive 1? Arc sine y value between negative pi over 2 and positive pi over 2. So it's up at positive pi over 2. Is that working? Okay, so then I have tangent parenthesis. What about this one back here? I have to do this as well. Where is the cosine 1/2? Pi over 3. Now, it wants us to do parentheses first. So what's the difference here? And then we're going to find the tangent. Type 1/2 minus 1/3 on your calculator if you need to do a math enter. Leave off the pi. But if you get a common denominator, let's see. This would be 3 pi over 6 minus 2 pi over 6. So we get 1 pi over 6. Did you get 1/6 when you did it on your calculator? Okay. So now it wants us to go to pi over 6 and find the tangent. It's just a lot of steps on this one. At pi over 6, the ordered pair looks like this. Did I get it right, guys? So then the tangent would be y over x, which would become, yeah, whew. That's the answer to that mess. All right. Do you have this number 22 as well? Okay. What did it ask first? Guess I should have. Where's the tangent negative square root of 3? Okay. Where is the tangent negative? Well, the tangent, I have to look in quadrants 1 and 4, and it's going to be negative in quadrant 4. And I want it to be negative root 3. Does everybody get that that would be here? Because when I put this y over this x, I'd have negative square root of 3 over 1. Okay? Which is what they wanted, right? Just negative square root of 3. So this was negative pi over 3. Okay. Now, I'm not doing an inverse sign, so no matter what quadrant I'm in, but what is the sign at negative pi over 3? So what's the sign at the same spot? We were here, so it just wanted the sign once we found that spot. So the sign was just negative square root of 3 over 2. Everybody good? All right, we're going to continue on with some notes on worksheet 21. Do you have this example, the top? Okay, this is an important example. There will be one like this on the quiz. Is this something you're going to find on your unit circle? No. Even though it's a tangent, which is hard to find on the unit circle, there is no 3/4 on our unit circle. So what we have to do is draw this, okay? And I think I might have even put on the quiz like hint draw or something, okay? But what tangent, what quadrant is the arctangent negative?
4.
Inverse tangent is in these two quadrants, right? Here's your little colored unit circle, very tiny down here. But arctangent is negative down here somewhere. So this is where I'm talking about drawing this. And I need to label the tangent on that triangle right there 3/4. What is tangent?
Oh, it's my word.
Okay, it's y over x or opposite over adjacent. So the y value is 3 and the x value is 4. And which one gets the negative? Because it went down. Okay. Opposite over adjacent, we're talking about this angle in here. Everybody okay? Then once you've drawn, this one is a 3, 4, 5, because once you've drawn it, we want the cosine, which is adjacent over hypotenuse, or x over r. So we do need this value. So we would do Pythagorean theorem, and it does come out 5. So then what is the cosine of that picture? Yep. Not that bad, especially if I gave you a hint to draw it. You just got to do it inside out. All right. I don't know that you have these two. Do you have this one?
Yeah.
Okay, good. Go to pi over 3 and find the sine. Does everybody understand that it just wants the sine at pi over 3?
Yeah.
And up here at pi over 3, the sine would be what?
Really?
And then it asks, where is the cosine square root of 3 over 2? The cosine is square root of 3 over 2 down here at pi over 6, right? Yes, everybody okay seeing this? It doesn't help if you're not looking. Okay, number 7b, is this going to be on our unit circle? No, so we're going to have to draw. Now, arctangent that's positive. What quadrant would I put this in? So this is telling me I'm in quadrant 1 because there's an inverse tangent or arctangent that's positive. Okay, how am I going to label my picture? 5 goes where? Opposite. And the 12 goes, okay, or y and x, right? Yep, 12. Why am I thinking about 13? Yes. Legs squared plus legs squared equals hypotenuse squared. 25 and 144 is 169. So we get 13 here. That's, my brain was jumping ahead. All right, did I need that? Because I want the sine of that picture. Sine is opposite over hypotenuse, or y over r. Not so bad. We've been doing these draw ones for a while. They're just different hints than we were using before. We started doing them in 4.3. Okay. Now, this is a little nastiness, and I think there is one on the quiz. But they do these all the time in calc. It says, write the tangent of the arcsine of A as an algebraic expression of A that does not involve trig functions. Okay, so what you would have to do is think of when you have a sine of A, sine is opposite, I'm just going to write it this way, but the sine is A, or A over 1. So if I were to put that on a picture, opposite over hypotenuse would be A over 1. Now we need to come up with an expression for down here. And students do the craziest things on these. They kind of forget that you can't simplify. Everybody understands that when we do this, we have to go 3 squared plus 4 squared and then square root, right? We can't just go 3 plus 4 and get rid of the square roots, because this comes out square root of 25 or 5, not 7, right? Can't just get rid of the square roots. So the same thing is true here. I'm trying to find this side. I'm just going to call it, should I call it x? Okay. So x squared plus a squared equals 1 squared. And I'm trying to solve for x. How am I going to get x by itself? subtract a squared. What's 1 squared, guys? 1, so we can leave that, but then it's minus a squared. That was a 1, sorry. Now what? To get x all by itself, I have to square root. I can't simplify. So the answer that goes here is square root of 1 minus a squared. And then it asked for the tangent. Okay? Right up here it said after you finally figured out how to draw that, find the tangent. Well, tangent is opposite over adjacent, so we'd have a over square root of 1 minus a squared, which they even rationalized. Ugh. So they multiplied by 1 minus a squared over 1 minus a squared under a radical, and they got a square roots of 1 minus a squared all over 1 minus a squared. Was that done for you on your paper, hopefully? Okay, because that's just gross. But you have some like this on the homework and one on the quiz. And it might not be exactly like that. It depends how it's set up. So let's try some of these. Do you have these two? Okay. So this says you have a cosine of x. We're just going to do it in the first quadrant. Always do it in the first quadrant unless it tells you it's negative or something. Cosine is x. Where does that go? I can make that x over 1, right, guys?
Yeah.
And the cosine would go where? Yeah, adjacent over hypotenuse, which thankfully is where the x belongs. Now we need the sine of that triangle. So do we need this side over here? Okay. You want me to call it y for a minute? If I call that side y, what are the two legs? Equals 1 squared, right? What am I trying to get by itself? The y. So I'm going to subtract y squared equals, what's 1 squared again? 1 minus x squared, and then square root, and can I simplify ever?
No.
So it's just square root of 1 minus x squared. All right, and then it wants the sine. So what am I putting over what? Square root of 1 minus x squared over the hypotenuse, which is just 1. So this is our answer. Thankfully, we didn't have to rationalize. Yes. They're not always minus, though, guys. Just so you know. Depends where the 1 goes and what they give us. All right. Let's try B here. Quadrant 1 again. Where's the x go this time? This is confusing. The sine is x over 1. Well, cotangent does not flip over cosine, right? Cotangent, if it was cosecant and sine, then they would flip over and we would be good. But this is cotangent. All right. I don't like this question. I wish they'd used n or something, because where do we have to put the opposite and the hypotenuse? That just seems wrong to me, right? Because it looks like it should be a y. Okay, how are we going to find this expression that goes down here? Plus whatever that is we're looking for, right? So we do 1 squared, which is 1, minus x squared equals what we're looking for. Square root that, yep, same old thing. Okay, what's the cotangent? Yes, which is adjacent over hypotenuse. So it's square root of 1 minus x squared over x. Okay, these are miserable. Let's practice them on our homework, maybe. Oh, do you have these two? You have these two on 21B? Is this also on 21B? All right. Well, you know what? Let's skip those two for now. Let's just do a quick practice on these, and then we'll do some right off the homework where you have to do that Pythagorean theorem garbage, okay? Real quick, where's the sine square root of 3 over 2? Just use your unit circle. Where is the tangent -1? Be careful. Tangent is y over x. Tangent is y over x. So Kelsey said if they're the same, it's going to be 1, right? But it needs to be negative. So that means we're in quadrant 4 because that's what's colored for arctangent. And she said negative pi over 4. She was on top of that. Where's the cosine -1/2? Be careful because arc cosine is negative. That's the one you look in these two quadrants, right? So -1/2 would be 2 pi over 3. Everybody okay? Okay, where's the tangent square root of 3 over 1? What kind of an ordered pair are we looking for? Yeah, this one I'm thinking. Does that work? So that the tangent would be this over this, which happens at... All right, weird one. Inverse cosine of 1. When is x 1? At 0, right? And what is the sine at 0 radians? What is this? Oh, this is hurting my head. I think this is a draw question because the cosine isn't ever supposed to have that, is it? Okay, but are these going to cancel each other out? The cosine is positive if I have adjacent over hypotenuse. What is the cosine of that angle? It would just be this, which would be, yeah, that's a gross question. I wouldn't ask you that. Okay, is this a draw one?
Yeah.
Okay, so it's positive. I draw it in quadrant 1. Sine is opposite over hypotenuse. They're trying to trick me. It's not 13. So I have 5 squared plus x squared equals 12 squared. This is 144 minus 25. Is that 119? Somebody check me. Is that right? Okay, so x is a square root of 119. So what is the cosine of that picture? Yes, adjacent over hypotenuse. All right, here's one of our icky ones. It does say here where x is greater than 0, that just means it's positive, so we're in quadrant 1. Okay, the sine is x over 5. Well, sine is opposite over hypotenuse. I really hate that they use the variable x, but again, how are we going to find cosine? Okay, we can use a. Okay, and we need to get a by itself, so we're going to subtract x squared. And what's 5 squared? We should simplify that. So we have a squared equals 25 minus x squared, and then we need to, and we can't simplify, cannot simplify. So this is square root of 25 minus x squared. Yes. Okay. So you're telling me 5 squared minus 3 squared, you can simplify. Okay. This is 25 minus 9, which is 16. The square root of 16 is 4. if you simplify this the way you want, I think you'll get this, which is 2. It's because anytime you have a square root, you have to do what's in there first. So I can't simplify. Yep. All right. Cosine. Adjacent over hypotenuse. Can you read that? I squished it in there. All right. Your assignment tonight is to finish up all this stuff that's on, but look at 22. Yeah, you have to do worksheet 22. And I know there's quite a few, but you need to practice. All right, let's try one of these. Want to try A or B? Okay, A. This is on 22B in the middle of the page, maybe? Did you find them? It says, where's the tangent x, or x over 1? So how would I label my little triangle? Opposite over adjacent. Now be careful. Cotangent. Well, what is cotangent? Yes. So what is the cotangent of this picture? That one wasn't complicated, right? Okay, I think B is kind of the same thing, so let's skip before we run out of time and try C. Okay, on C, how am I going to label this triangle? I have 4x over 1 opposite. Oh, this is just x, no 4? Oh, that was kind of me. All right, so you're going to have x over 1 for the tangent, opposite over adjacent. Okay? Now be careful. I'm looking for the hypotenuse this time, so what do I have to do with the legs? Yes, I have to add them. I'll just write hypotenuse squared here. So then I can square root both sides. Does that simplify it all? Well, except for what 1 squared is. So this is 1 plus x squared, because it's the hypotenuse, so it's longer. Now, how do I write secant? Oh, thank goodness I don't have to rationalize. Secant is hypotenuse over adjacent, because it's the flip of cosine, which is just square root of 1 plus x squared. Let me try D really fast. Cosine is 2x. Where do I put that? Adjacent over hypotenuse would be the 1. Am I adding or subtracting to get this side? So it's 1 squared equals 2x squared plus, I'll put question mark squared. So I get 1 squared minus 2x squared, and then I have square root. Well, square root of 1 squared is, or 1 squared is just 1. But what's the trick? Everybody's getting it wrong. 2x squared is not 2x squared. It's what? 2x times 2x is 4x squared. So then what's the sign?
1 squared.
The square root of, yes. All right. So this homework is important. I would definitely try to do a few of these tonight so you remember what we were doing. Because if you wait and do this next week, that's a long ways away, right? But you need to prioritize getting ready for that quiz